Hey everyone, and welcome to this episode of Hacker Talk. My name is Philip, and I will be your host in this episode. Today, we're gonna deep dive into writing malware in Golang. I'm really interested to hear more about Golang, and with me today is someone that's done a lot of research in that space. Our guest did his first DEFCON talk at DEFCON 13 in 2005 and has been in the infosec community for a while. He's host of an awesome podcast called Hack the Planet Podcast, featuring various interesting guests, partly in the Golang infosec space. So you gotta go and check that out. Joining me today is the amazing hacker Ben Kurtz. How are you doing today, Ben?
Oh, pretty good. Pretty good. How are you?
Good, good. So you've been in the infosec space a while, right?
Yes, almost 20 years professionally. It depends on how you count. I was actually into kind of hacking and sort of 2600 meetings, and
Nice.
I used to run a bulletin board. I used to run a bulletin board, like a dial-in bulletin board that was pretty hacker themed back in, the early to mid 90s. And then I was in high school, and then going way back, I think my first exposure to computers, I kind of learned how to program an Apple II when I was like a little kid, maybe
Okay.
6 years old. Of course, you have no money when you're 6, right? And so like I was almost immediately after getting a computer, you had the problem of how do you copy protected disks, right? That's like the day 2 problem of getting a computer, even when you're 6. So my kind of peripheral knowledge of some security topics goes back, to about the time I was learning to swim, slightly before I actually learned how to ride a bicycle.
But how did you get into hacking and security? And why hacking and security?
Oh, well, that was it originally. Originally, it was to pirate Apple II software. And then later it was to cheat at SimCity. As things got more connected, I got into bulletin boards in the 90s. We started to get some inkling that the internet was coming, right? But initially, if you wanted to get on the internet, you had to go through a university. So you would dial into a university like a modem bank and get onto the internet that way. So there was the whole era of my life that was devoted to figuring out how to get onto university computer systems just so that I could access the internet. And so that involved a lot of kind of old-timey Unix security topics. When I was interested in that kind of thing was actually before the shadow file was invented. So at the time, a lot of the game was related to world-readable files in the Etsy folder that you could kind of take home and crack passwords or whatever, and try to escalate privilege. So I've actually been sort of directly following the evolution of network security in that sense since, I don't know, 1994. So what year is it now? I don't know how long that's been. But, strangely enough, that I always thought of that as a hobby. Like I used to program. I was obsessed with computers. I would stay up all night, working on my bulletin board or just like playing some weird game. And then I went to school and I had no idea that like computers was something you could do for money. Like I didn't know it was a job. So I had no sense that I was going to school for computers. I just sort of was going to college. And then I just kind of signed up for all computer classes, and I was very pleased to find out you could just do that. And I didn't have to learn some other field, to make a living. I started doing programming then for a while because I really do enjoy programming. But after a few years as a programmer, I worked for a startup. I was the main developer for a startup that made a security testing appliance.
Mm-hmm.
And it was when I was working for that, it was called Imperfect Networks. They later got bought by Spirent. And they it was working that job that I ended up giving my first DEFCON talk, because I kind of came up with some sort of simple ideas related to fuzzing, and the CTO of the company was like, "Oh, you should go to DEFCON and talk about it and kind of like send some attention our way or whatever." Or they just wanted to say that their lead developer had like spoken at DEFCON or something. And I was like, what's DEFCON? I had no idea. And so I went to DEFCON and I gave a talk, and I had no idea what was going on, and I had a great time. And I went back to being a developer for a couple of years, but I kind of always had that in the back of my mind. And after a couple of years trying to be a regular programmer, I just started working on this side project where I actually rewrote a lot of the core technologies that the startup had involved and sold to Spirent. I sort of rewrote it all in Lisp because it made some sort of sense at the time. And I gave another talk at DEFCON a couple years later with that as the topic. And I also I immediately flew to CCC camp and I gave the talk again. And some people from Seattle, I was living in Massachusetts at the time, which is the East Coast of the United States. And some people from Seattle, it was Josh Pennell and Dan Kaminsky, saw my talk, not in Las Vegas, but in Germany, they saw the talk. And they came up to me after the talk and asked me if I wanted to move to Seattle and be a professional hacker.
Oh, and, cool.
I was sufficiently bored in New England. So I thought, sure, yes, let's do that. So that was 2007. I moved out here like the end of 2007 and I've been working in the security industry professionally on the West Coast ever since.
Nice. That's awesome. So you mentioned that you were doing Lisp. How has your programming journey been? Did you start with Lisp or you start with assembly, I assume? Or
Oh no, I learned assembly late. I learned in a weird order. So I've thought a lot about how people learn programming. It's very difficult for me to kind of think about how other people learn programming. Like I have to really, really think about it because I learned so young. And if I had any advice for anybody who wants to learn programming, it's not going to do you any good if you're old already, because my advice is learn very young, right? Because there's just a handful of basic concepts, branching, conditionals, the kind of logic, it's almost the algebraic logic, but real simple, right? And once you get your head around that, once that's not scary, programming in any language is just kind of a matter of what you want to do, and you just need to look up how you do that in a specific language. And you can do it in like 10 seconds in Google, and it's like all these programming languages, they have surface differences, but most of the fundamental concepts are exactly the same across all programming languages. Right. And initially I learned AppleSoft Basic when I was very, very young. And that was the one where you had to enter the line numbers. I have all of my original discs. I actually can show you. They're on the shelf behind me. But I have all this code that I wrote when I was 6, and it's hilarious because even at the time I was like bizarrely paranoid that someone was going to like read my source code. So I have this one disk that has like 4 different passwords, not that necessarily makes any sense practically speaking, but it does sort of demonstrate that I was interested in this topic from a bizarrely early age. Anyway, so after AppleSoft Basic, we did a little bit of Logo in school, but I kind of never really got it. That's the one with the turtle and you're giving it vector directions. I did have a very, very early introduction to vectors, which I guess turned out to be sort of interesting. When I was running the bulletin board, I started to learn C. And because I used to write modules for my bulletin board that were written in a kind of C-like language, I used to run PC board. Old bulletin board software is very faction-based. So 90% of the people that knew what a BBS were just went, oh, you degenerate, backslider, heathen. And some small percentage were like, yay, PC board. But so I kind of learned C through PC board. And I also learned Pascal randomly from some old man that worked in a basement in downtown Milwaukee, where I grew up. Okay. So my dad wasn't a computer guy, but he kind of got a sense sometime in middle school that I was like getting into computers. So he like asked around if anyone knew about computers, and the IT guy from his building at work knew some Pascal. So he like taught me some Pascal at some point, which was pretty weird. I mean, he was cool, but Pascal is just a weird language. But I did have some exposure to Pascal. I had some exposure to C. We didn't have any computer classes in high school at the time I went, like nothing, Python didn't exist. So I went to college, and at the time Java was getting big. So I learned Java. I got really into Java, and I also learned Lisp, specifically Scheme. And I kind of had a a bit of a love affair with Scheme for a few years there. And I still appreciate functional languages, and I know what they're for, right? Like, so there are certain problems where if you want to solve that problem, you are probably going to reach for a functional language. The best example is constraint solvers. It is trivially simple to implement a constraint solving system in a Lisp-like language. There is an example of it in the Wizard book, the Structures and Interpretation of Computer Programs. There is a chapter in there of like how to write a constraint solver. It's like only a few pages long, and like you can wrap your head around it. If you try to write a constraint solver in C, you're going to have a bad time. And so I am a firm believer in the right tool for the right job. At least I was until a few years ago when I discovered Go, and I got super lazy. I used to, learn all these different programming languages. It's like I've written, I don't even know. I wrote programs for like Visual J++, which was Microsoft's predecessor of .NET, which the Supreme Court made them change to be less similar to Java. And I think that's when they kind of went back and came up with .NET. Just a theory. I don't have any inside information on that, but I did a lot of development in C++ professionally, and in C#, in Java. I've written some Ruby. I've written a lot of Python. I don't even know, like tons of like, I've written a shell script probably every other day since I turned 18. Like, I don't even know. Like I've put a ton of code in GitHub, but that's just a small fraction of sort of what I've spewed out over the years, most of which is terrible. But I came across Go, and it just kind of tickles a certain part of my OCD, So I had some exposure to Plan 9. So Go came out of Plan, the Plan 9
assembly. Yeah.
Yeah. So Plan 9 was an operating system. It was a Unix-like operating system where basically some folks at Bell Labs, who all had a particular form of OCD, decided to redo Unix so that everything was consistent. Right. And they went through and they just redid Unix so that everything was consistent and didn't worry about if it felt weird or anything. They were just like, everything is going to be totally consistent because we need it to be totally consistent. And they came up with this they call it an experimental operating system, mostly because nobody ran it in real life. It's a really common experience for like computer science students to like install it as a lark on something and like try to use it for a week or two and then just be like, that was too weird. Like, I feel like I learned something, but I basically never want to do that again.
Never touch that
like
VM again.
Yeah, it's kind of like OpenBSD for most people, although some people spend years in OpenBSD land before being like deprogrammed, like you don't have to, you shouldn't be expected to like manually modify all your network drivers just to get on the internet. Like, that's not reasonable.
Yeah. I mean, yeah, and they say they intervene so much. I mean, I've spent a lot of like all my switches at home run OpenBSD, but then I switched to FreeBSD, and I'm like, isn't this almost supposed to be the same? And it's like two different words, two different words, but they do some cool stuff.
And working as a security consultant, I was reviewing other people's code. I was finding bugs. I was writing exploits for years and years and years. So I was exposed to all of this other people's code could be in any language at all. Right. So I've been writing all kinds of different languages. I've been reading, everything. And I came across Go. The only thing I ever read about Go initially was on the golang.org page. There is a paper called like Effective Go or something like that, which is just, it's just a list of the language features that are different than C++. And that's it. There's no exposition. It's not very verbose. It's just like, this is what you need to know about Go if you already are a C++ programmer. And I read that and I was like, oh, this makes total sense. And in a weird way, it's like the Plan 9 design team redid C++. That's kind of what Go is. So they went through and they made things very consistent, syntactically, right? Like things that are always on the, things that are on the left somewhere are always on the left, right? Like, and you especially notice that with data type, like int or whatever, like data types. In C++ land, some things can kind of be on one side or the other depending on circumstances. There are pros and cons to Go. Some that I knew up front and some that I've learned. But why it's kind of my favorite language, it just has to do with how fast I can go from having an idea to having a working program and being done writing code.
Very efficient.
I feel like some programmers, I don't know if it's a matter of age or just personality type, but some programmers, they just like to kind of pick at something forever.
Yeah.
And I'm not one of those people. And that's kind of why I didn't really last as a professional developer. I love designing the thing and cranking out the prototype. And then I wanted to move on to a new project, and my employers would always want me to sit on the thing I wrote and maintain it forever. And I would get super, super bored, which is why I actually love consulting, because it's like a different thing, every couple of weeks, or just, working as a security engineer. But Go, just the workflow, maybe it just syncs with my brain, but it's like the tool chain, the fact that almost all of the crypto libraries that I want are built into the standard library, and also just the availability of other people's code, like working libraries that do everything that I want to do, means that if I just pick up Go for any random thing I want to do, I'm going to be done with a working stable program way faster than if I reach for any other programming language. And that is, a lot of it has to do with a lot of the things I'm doing are like network programming, or they involve crypto. If I was doing a lot of UI stuff, Go has no UI package. There's no way to do UI for Go. Yeah, it's incredibly easy to crank out a web server or like a REST API. And then you can do your whole UI in like JavaScript and just have it call down to Go REST APIs. So that's normally what I end up doing. But I do wish I lived in a world where I never had to touch JavaScript, but
it's a necessary evil, as my friend said.
It's a necessary, needs must.
Exactly. How was the syntax in the beginning of getting started with Go? Was it a steep learning curve, or was it easy to get into?
Oh, for me, it was no problem at all. I read effective Go in one sitting, and then I was like, I'm gonna go write something in Go. And a lot of people ask me how to learn something, how to learn to hack, how to learn to program. I run a lot of workshops teaching hardware hacking, or like how to write malware is what I've done a few times. The only the best advice, I mean, I kind of came up with this myself, but if you search for variations of this quote online, apparently Napoleon said this, some ancient Confucius said this, some ancient Greek generals said this, but the only way to learn anything is to do it. So what you have to think about, if you think academically, I want to learn something, that's not going to get it done, right? What you need to do is you need to put learning that thing between you and something you want.
And you gotta create some kind of carrot or some kind of goal.
Yeah. I often have these ideas for programs that I want, right? And if I want to learn a new programming language, I basically just decide to use a new programming language to write this thing that I wanted to write anyway.
Yeah.
Right. And for me in Go, the project that I wanted to do was RatNet, which is this mesh routed encrypted messaging middleware thing, which is kind of how I got into Go Malware eventually. But I had this project I wanted to do where I wanted to do this encrypted mesh routing thing. And I needed it to be very stable. There was going to be a lot of crypto. And, I wanted to do a lot of asynchronous operations efficiently. So when I read about Go, I was like, oh, hey, now that sounds promising. And then when I actually sat down and started writing the code, I just was cranking code out. And it was no it was like no programming experience I'd had up to that point. Just like the rate that I could crank out code was totally astonishing to me. And that's why I use it, right? But if other people like other languages, I don't get upset, because it's like, maybe they just don't kind of resonate with Go the same way I do. Maybe they resonate with something else.
Yeah, you gotta find what works for you, I guess, or something you can feel productive in or be productive in. How did you go from the RatNet network to writing malware?
Well, so I got into the RatNet project in kind of a strange way. So this was years and years ago, and I don't even remember how many. I think slightly less than 10, but things are getting really hazy now. It feels like 2020 might have taken a full 10 years or something. So I've lost all sense of time, but somewhere, I think slightly less than 10 years ago, I was doing a little bit of volunteer work around some privacy programs. I ended up sort of working with the Tor developers a little bit.
Okay.
And I was kind of looking at one of the earlier versions of their obfuscation proxy. And it was kind of around the time of a particular Iranian election, where the government of Iran was shutting down TLS connections that were headed out of the country, because it was like leading up to an election and people were trying to tweet, and Iran was like they were trying to force people to like authenticate to Twitter without TLS, but that wasn't going to work. So I don't really know what was happening, but they were just like blocking all TLS connections. They were trying to, prevent people from anonymously tweeting about the election. And there were a bunch of people all over the world who were working on technologies to route these tweets out of Iran and to Twitter. I don't know if that ultimately did any good. It was successful in some ways in like getting traffic out, but I don't know if tweets like, ultimately changed anything. But I think it was a good trial balloon. And there were similar efforts at subsequent Iranian elections. So I think it is really good for, people to kind of participate in these kinds of anti-censorship activities, because at some point we will get something working really well. And, it's a little bit of an arms race, right? Like, it's like the anti-censorship side will get something working. It'll work really well. And then eventually, the censoring country, China.
It's a rat race there.
Yeah. But a lot of countries do this. Actually, a lot of countries you might not expect do some kind of filtering on the internet. And something else that happened back then that was kind of on my mind is there was a protest in the United States in San Francisco at a BART station. I think it was the Eric Garner one, where the police had killed somebody for no good reason. Yeah. And there was a protest at a train station. The BART's the train in San Francisco, and the police. Part of it was sort of underground, right? So there was the cell phone repeater that was for the train station that the police just turned off during the protest. They decided to crack down on a protest in the United States, in San Francisco. So not like Oklahoma, where if something scary happens, the government does something scary in Oklahoma, you're like, well, it's Oklahoma, right? But this is like San Francisco is like supposedly the most, liberal left, whatever. And it's like in San Francisco, the police, because they were about to crack down on a protest that was not a violent protest, and it was a protest for a good reason. It was just sort of against police brutality. So the police wanted to be brutal, so they turned off the cell phone for the train station, and then just like went in and clubbed people, right? And so my train of thought here is that what's kind of changed about the world is that anywhere you can stream cell phone video from, it is going to be hard to do very nasty things, It is difficult to do very nasty things for a long time if people can just stream video out on their cell phones, right? So the key thing that is preventing, people from doing nasty things is the ability to stream video out on your cell phone from wherever, right? More or less,
Yeah.
So
it's on a protocol level almost, then you could say.
Yeah. Well, so those were the problems I had on the brain. Basically, the government could turn off the cell network if it becomes convenient for them to do so at any time. In the U.S., they've done it. In any other country, they'd probably do it too under the right circumstances.
In Sweden, it's very common that to do it, but they have these like big jammers that they GSM jammers that they put in vans at protests and just run that out.
Yeah, or you could just jam GSM too. So, and I had been working on this obfuscation proxy for Tor, and that the purpose of that was just to mask the initial connection to Tor so that it didn't look like it was over TLS. And they still have, and the version they had at the time was version 2. It was terrible. I found a bunch of problems in it, and I started thinking like I didn't like the design. So I started thinking if I was going to design this from scratch to solve this problem forever, what would I do, right? And that's kind of how I came up with RatNet. It's not to reinvent Tor. Tor solves a sort of different problem. Tor is sort of the best solution for the problem it's trying to solve. But what I was trying to reinvent the obfuscation proxy part of it, and I kind of got a little carried away. So you can be familiar with Tor, and it kind of doesn't matter. Like I sort of did a different thing. So what I did is I made a kind of messaging middleware. So it handles you just send it a message and it handles everything else. It delivers the message to the other end. And you kind of don't need to deal with that logic from application space, but basically it's end-to-end encrypted. Okay. And it batches messages up through repeaters, and they are also encrypted in different sized batches. All right.
Oh, cool.
And you have a bunch of knobs you can twiddle. So you can add random jitter, and so you can kind of alter the size of the batches. But there's
to make it harder for people to make signatures for them and stuff like that.
It's a way of breaking up correlation attacks.
Oh yeah.
But also the way the messages are encrypted on the wire. There is no way of figuring out who the sender is, right? And you can only figure out who the recipient is if you know the recipient's public key already. Otherwise, everything you see on the wire is apparent entropy. It also supports pluggable network transports. So every hop can be over a totally different network transport. So it can be network transport plugins we've implemented. We've done packet radio. We've done TCP, UDP, web fronting, DNS, quick. There's an SSH one. We're going to probably do an ICMP one at some point. But the idea is like you can use either internet protocols or other, like any other protocol. Like the packet radio one isn't using IP. It's assuming that you have access to entirely different hardware. And that was a design requirement from the beginning, because I thought, what if I wanted to do like a microwave hop or like a laser hop or something? And it also supports one-way network protocols. So it would theoretically support situations in which you can send, but not send and receive, because it is a message store and forward system similar to Usenet or NNTP or even like Freenet. Although I don't like to bring up Freenet because I don't want the people using Freenet to ever use my thing. I think they should just stay on Freenet. It's fine.
What happened to Freenet? It was like, I feel like it was big a while ago, and then it just died, and no one ever talks about it.
Okay, look, I mean, it's basically the same thing that happened to Second Life. It's basically just Nazis and furries now.
Uh-huh.
So, and they're not always mutually exclusive anymore. Like they've been hanging out online long enough that now there's crossover. So that's a thing that now lives in your brain. Yeah. I mean, it's like, it would be hilarious if I made that up, but I didn't. Like my imagination's not that good. So it's just kind of like, well, yeah, if that can happen, who knows what can happen? It's kind of unnerving, you know?
Yeah.
But it is actually sort of like, it is really fascinating. These like online communities that get abandoned, but never really turned off. And then they develop these weird, like second lives, so to speak. You know, Second Life is one of them, but there's all these old chat programs that people don't know are still running that are pretty interesting. And old file sharing software that people don't realize is still running, which is a surprising good time. But
to find
anyway, so yeah, exactly. To get back on topic though, so RatNet, I basically made a system for sending messages that can avoid any kind of pattern matching system. You can time delay things. You can change the size. You can use different network protocols over different hops, and it's very easy to use from the program logic point of view. You're just calling a library. You're cramming your message in. You're waiting for messages to come out in the callback, and that's it as far as you're concerned. And you can set up multiple nodes, and they'll all route between each other, right? Because the other thing this actually supports, the other use case, because this is what I built it for in the first place, is actually offline mesh routing. So I have this running on OpenWRT routers. Like I bought these little battery powered OpenWRT routers for like $30 that they don't really sell them anymore, but they were selling them for a while. I have a bunch over there. And so I got Go cross compiles to MIPS 32 soft float, which is another reason I love Go. So I can cross compile my Go programs to OpenWRT. I did have to change all my crypto over to ECC. RSA on a MIPS 32 soft float is prohibitively slow. If you look at the benchmarks, you would not think that was true. You would think that other than key generation, RSA should work, but it just doesn't for some reason, but ECC is fine. So I figured that out. And I used 802.11s to make these, so I could set up multiple of these little OpenWRT things. And when they came into mesh range of each other, they would find each other and they would exchange messages. And then when they move apart from each other and they pair with some other node somewhere else, they connect with that node and they exchange messages there, right? So it's not particularly efficient, but I basically just flood route messages. You send everything everywhere because it's encrypted in such a way that no one in the middle can read it or tamper with it. Only the end recipient can read it, right? And at some point, things, they hit the edge of the network and die. But the idea was to make this also work with offline mesh. Okay. Now these two properties, I also keep in mind that I'm working as a penetration tester this whole time. So a lot of my friends are red teamers. I do more of the technical pen test thing myself. I more read the code, find the bug, write the exploit. I don't go through the people for the most part. I have done some red teaming, but usually someone else in the organization is doing more red teaming than me. But I do have a lot of friends that are doing red teaming. And they have gotten into the business of writing their own implants. And the red teaming these days has become a lot about EDR evasion, right? Like getting the basic red team stuff that used to be easy in the old days. You used to just walk into the building. I used to just hang out by the smoking section with a pack of cigarettes and wait until someone left the building. And I'd wear a polo shirt. And I'd wait until someone left the building to smoke a cigarette and ask me to bum a cigarette. And then I'd bum them a cigarette and then I would tailgate them back into the building. Right. Because that's like a zero risk tailgate. Right. You could try just to tailgate into the building, but if someone is slightly obligated to you somehow, that's better. But, since that time, the EDR systems have gotten stronger. The anti-tailgating training videos have gotten more direct. And almost everyone has quit smoking, right? So, well, at least around here, when I go to Germany, I'm surprised that it seems like everyone is still smoking. It's like, oh, right, this used to be a thing. But so my old tricks don't necessarily work anymore. But I haven't done that much red teaming. So the people that are doing red teaming now, a lot of what they're focusing on is getting their own kind of implants, right? They're writing their own malware and they're customizing it to work around the EDR systems that are deployed at their current target. And then they're maintaining their own command and control servers for those implants to phone home to. And it turns out that having all these network transport plugins ready to go makes for pretty cool implants and C2 servers, right?
Oh, so you
like
can use
DNS exfiltration.
you can use that
So,
to tunnel through the firewalls and evade the detection.
oh yes, especially DNS. DNS is a big one. UDP, MDNS we've had fun with. There are some things that do get flagged now after we've been at this a couple of years that didn't used to get flagged, but that some of it was probably our fault. So I basically had all these red team friends. They found out I was working on this project. They started thinking I was doing it as like a protester thing. Actually related to the original RatNet project, I'm actually working on a handheld device. So I'm making some custom hardware that will be a handheld RatNet-based messenger. It's going to be an OpenWRT router with a built-in keyboard and an e-ink display, and it's going to run on a vape battery. It runs on an 18650. So hopefully I'm going to get that out probably late next year on Crowd Supply. I'm trying to get a prototype to Crowd Supply that is not totally ruined, so it's good enough for pictures to start the campaign. So hopefully I'll get that done in the next few weeks. So I am still sort of pursuing my original purpose of RatNet, which is it's a way for protesters to communicate with each other, even if the cell towers are off. It is a zombie apocalypse internet solution that you can run on old phones that you dig out of the dump. I don't know. It's all in Go. It's pretty neat. The code's in GitHub. You can check it out. My GitHub handle is AWGH, and that particular project is called RatNet. I also have another a GitHub group there's a bunch of code in called Binject, capital BINJECT. So it's GitHub/Binject. That has a bunch of sort of core components for some of the malware. But the RatNet repo is over in my personal stuff in OGG. Anyway, so my red team friends found out that I was writing this like ultimate exfiltration library, and we started kind of getting together on putting these larger malware packages together, implant and C2. So we made a lot of different C2s and a lot of different implants. Me and one of my red team friends started doing private trainings for professional for money, like big, we charged like full training cost for this. And so the people that would show up would be like corporate red teamers. And we started doing trainings on how to use Go to write implants and C2s and write malware, like some EDR evasion, IDS evasion, how to do the crypto. And along with this training, we gave a lot of these people a full working implant source code and full working C2 with source code. And some of the people that actually went to our first training were the people that went on to develop Sliver, which is now which is an insanely awesome Golang based command and control server and implant building system. And it's one of the like top 10 C2s on the planet. It did make it several years only used by professional red teamers. There have been a couple of public incidents in the past year where actual people, illegally hacking into things have actually used Sliver a couple of times now. But it's meant to be an entirely open source replacement for Cobalt Strike. People are working on it continuously, including I help out here and there. You'll notice they're using a couple of my repos here and there. But we also are all just hanging out in a chat room all day, kind of sharing ideas and asking for help if we get stuck on stuff. And it kind of just snowballed, right? Like I had some initial red team friends, some of them were working on Meat Pistol. I had some crossover with those guys. And then, we did this training and we met all these other people that then got super into Golang. And then, we just started hanging out in a chat room. All these other people started joining. They're working on all these other projects. And, after a couple of years of that, we've had a, very active community. All of a sudden everyone's been working on these utility libraries that do all kinds of different things, that solve all kinds of different problems. And we got to a point where it's, we're the what you can kind of build malware wise with off the shelf Golang components, kind of if you know what you're doing, all open source is, it's on par with Cobalt Strike, but it's, for free and open source, but it's also on par with any of the actual operators. It's like if you're prepared to do a certain amount of customization, just like actual operators do, then you can do all like just as well with off the shelf parts with Golang, just because the reversing capability for Golang is so bad at the moment. So Juan just gave a talk a couple months ago about really advancing the tech of like reverse engineering Golang binaries. However, it's so much easier to obfuscate Golang binaries than it is to reverse. Like they've just like the top of the line, reverse engineer people have just gotten up to basic Golang reversing. Some friends of mine have been working on a Golang obfuscator, a next generation Golang obfuscator called Garble. And Garble we use Garble by default on just about everything at this point, and they haven't even started like working on how to reverse Garble yet, and it's like, even if they do get into reversing Garble, there's like stuff we can do to make it worse that we just haven't bothered with because we haven't had to yet. There's also all these just existing EDR evasion libraries and utilities for Go, like Scarecrow is a really common one. Scarecrow is like, it has a couple of tricks, like it'll unhook the event tracking from your binary when it runs, which can mean that it will not show up in the logs on some systems, depending on what they're relying on for logging. That would be a lot of this stuff is Windows only.
How do you
some Linux?
How do you test that it actually passes the antivirus once you have like created an implant? And how do you actually test that it's going to trigger? Do you set it up in a virtual machine or?
Virtual machine or even just a bare metal Windows installation. Basically, you want to set up your test environment as close as possible to your target. Obviously. Yeah, that usually means you're setting up a Windows box. Maybe you even want to set up a hack domain, so the Windows box can be in domain joined mode, as opposed to having a local account or whatever. And then, maybe you want to have like Windows Enterprise, and then maybe you actually want to set up the actual EDRs that you're targeting. And if there's a combination of them, you may want to set them up in combination. And it's even more complicated than that because a lot of them have different settings or different features that can be present or not present, that can make a difference. Carbon Black, for example, has a couple of different products. So when you're talking about, Carbon Black is installed, you don't necessarily know if that means like the detection or the binary whitelisting or what, right? No matter what it is, there's a workaround for it, but like you need to know kind of some information about how the target's set up. There are strategy, or you could use a different strategy, which is like you just pick some strategy that's likely to work on most things, right? Or you can just be like, I'm not going to get blocked by anything. I'm going to be loud, but I just don't think they're watching the logs, So, when a lot of times when I do this, especially if I'm getting towards the end of a pen test, I will start doing things that are supposed to be loud just to see if anyone calls me, right? And if
to check,
if nobody actually mentions anything that I did towards the end where I was trying to get caught, I actually complain about that in the final report. It's like, so this definitely should have gotten a human involved, Yeah. So the other thing, all these professional red teamers, the other thing they do, right? There's a competition every year, which is the CCDC national competition. So it's a collegiate, cyber defense contest where all of the college students are defending some network and they don't know what the network is before the contest starts. And there's teams from all the different schools that are competing, and they show up and they get their information about the network they're defending. And then the game starts. And you bring in all these old guys like me or my friends, and we're the red team or whatever, and then we're trying to hack into these poor college students, and so I'm friends with a lot of people that do the red team stuff for the national competition. And for a few years there, I was just helping them write special tools every year, before nationals that the college kids wouldn't be ready for, because they would have never even heard of this. Right. And so we got into this kind of thing where every year we had this deadline where we have to like write a bunch of innovative stuff. And that kind of sort of drove innovation there too, mainly to make college kids cry. But they have been trying to encourage the red team to kind of dial it back a little bit after the past few years, because they got into some. I mean, basically, since they switched to Golang Malware, it has been a lot easier to deploy variants of things automatically and have them and like control them from a C2, because there's all these components, available, right? And you can pivot if you need to just change the code and do something. It's like the odds you'll be able to find some component out there that does the thing you need. It's like very high. It's just it's a nice environment to work in, but it's really, I think, kind of swayed the advantage towards the attacker. And then in this particular contest, the attackers are the more experienced people anyway. So it does feel a little bit unfair. But one of my sayings is that I don't like to play games where I can't cheat. So I think there's maybe a valuable lesson for the college kids in there somewhere, I guess, about maybe you shouldn't expect job satisfaction working as a blue teamer. Someone's got to do it, but it's going to be like, the mail never stops coming. Yeah. It's going to be a hard time.
Yeah.
So, well, and anyway, yeah, just to tie a bow on it. So I made all these friends and we all have this Golang Malware thing in common. And
nice.
This culminate, and we wrote all these libraries. And this culminated in me actually giving a talk at DEFCON this past year. That is just, the whole talk is basically just a list of it's just a list of a brief description of as many of these projects as I could fit into a 45-minute talk. And I couldn't even fit everything in. And some things get a little bit more description than others. But I really just wanted to try and communicate to people that they're like how much of this stuff is out there, right? And the other kind of value that this talk serves is that when new people join our chat room now, they don't have to scroll back through like 3 or 4 years of chat history and links and people talking about stuff. They can basically just watch this talk, and it's like a 45-minute summary of the entire back history of the topic of like Golang Malware. Now the funny thing is, I have had this little, we talked in the beginning, we said we were talking about all these different programming languages, and someone just pointed me at this other programming language called V, it's called V, and it is a more lightweight language. It has a much smaller runtime than Go, which would be very nice for at least writing implants. So Go, even if you compile a stripped Go binary, your runtime on x86 or x64 ends up being like 800K. Which is big for an implant. That's a lot of overhead. That's just the runtime. That's just like the core library that you can't statically compile out, and like the garbage collector and the scheduler and that kind of stuff. But like V has Go-like syntax, but it doesn't have a garbage collector, and it compiles down much smaller. And I've kind of been feeling that inkling, like looking at V, I'm like, ooh. Maybe I should find an excuse to write something in V. So I made I can't promise to remain faithful to Go forever. But I kind of like that. I kind of like where that's headed, right? So if V feels like it's an extension to Go, or it's kind of addressing some of the problems that Go ran into while sort of keeping the same philosophy, like maybe it would even be possible to automatically translate some code from Go to V at some point. They're that close. But it also brings in some kind of Rust-like stuff, where it tries to like automatically free memory. But it's like explicit, it's like the compiler's adding explicit freeze rather than a garbage collector. I don't know. There's some like kind of new ideas in there I thought were cool. So A lot of the implant writers are switching to NIM. NIM is becoming pretty popular. That's another kind of weird language. And there's a few others out there that I've seen people use. Obviously Rust, but Rust has enough people that bring Rust up. They don't really need me to do it for them.
Pretty much. But I feel like Golang is getting more and more. It's becoming like the new Python, I think, in the infosec community. Everyone is rewriting stuff to Go, and even Mimikat's been rewritten to Go.
Yeah, it has. I haven't.
No, there's a fork here in my note. Go Mimikat.
Oh, that's not a rewrite of Mimikat.
Oh,
that's actually no. It is. So there are some partial rewrites of Mimikatz in Go, not the whole feature set, but certainly it's part of it. I have a private repo I might release at some point, which does some of the functions of Mimikatz as a Go binary. That's one of those things that I might wait until we get to use it at CSTDC before releasing the code. But the Go Mimikatz is actually it's a project of a friend of mine. It's a virus. He's a very good friend of mine. We work together on a lot of these projects, and I've actually helped out with Go Mimikatz. As you can see, it's using a lot of my repos, the latest version, or maybe the version before that. Virus rewrites it periodically as it gets detected by EDR. He rewrites it so that it doesn't get detected by EDR, and then posts a new version, right? So it's gone through a few different incarnations, and I've helped out with a couple of them at least. But what Go Mimikatz does, it's actually just an example of Golang EDR evasion foo. Because what it does, it goes out to the network, it just downloads Mimikatz from the network and runs it.
Oh, so it's just like a packer for
Yeah. It's basically just it's a Mimikatz loader. But the point of it is that at any given moment, if it's currently up to date, which it usually is, you should be able to just run that on a machine that is trying to detect you running Mimikatz, and it will just make Mimikatz work. And if you want, and the code is usually only a couple pages long. So the real moral of the story is, I want you to look at the source code. We want you to look at the source code and kind of understand what's going on, because you could use the same methods to make anything else work, not just Mimikatz. You could expect that if you were really paranoid, you probably don't want to be going directly to download Mimikatz from the victim network, right? Like, odds are no one's going to notice that. Like in the real world, no one's really going to notice that. Like, it might flag in some IDS somewhere, but no human will respond. And if they do, they won't know what to do. Like, but maybe you're on one of those like 1 in a million networks where they're actually on top of everything, you know, like everyone encounters like 2 of those in your career. I think I would say about 2, where everyone's super competent and you have to try really hard to win. I would say I've seen 1 and I'm expecting 1 more. So I'm guessing 2. That seems like a whole lifetime you see 2. It's my guess. Anyway, so but like if you were being, you know, like if they're really paying attention, you would not want to go directly to GitHub to download the Mimikatz binary, because maybe that's on some IDS blacklist. Maybe you're not even allowed to get directly to the internet on the network you're on, right? Like maybe you would need proxy credentials to get to the open internet from where you are. So maybe you can't even go to GitHub and in the first place. And so, but if you look at the source code to Go Mimikatz and you see, and maybe you wouldn't want to run Mimikatz either, because that's like the most sigged binary there is. So the whole purpose of Go Mimikatz is, look, we can run the most sigged binary there is, you know, using this trick and that trick and this trick at this moment, right? And yeah, so like shout out to Virus, that's a great project, but definitely look at how it's changed over time, because it's kind of the history of how detections of Golang malware have been changing over the past few years.
That's awesome.
But he's used a lot of different tricks. I think the first version was like one-time pads, like it would split the file into two kind of random things and XOR them together in memory, right? So it was never decrypted on disk. And then there was a version that used Go Donut, which was my Go port of the Donut utility, which is a shell a loader. Are you familiar with Donut?
A bit. No,
Yeah. So Donut. Yeah. For those of you who aren't familiar with Donut, Donut is a utility that converts any Windows executable into an injectable shellcode, and then it is also the loader that gets added to that shellcode, so that makes the system work. So I didn't rewrite the loader. I used the regular Donut loader, but I rewrote the utility that converts an executable into the shellcode to be in pure Go, so that you can run it from your C2, for example, even though your C2 is on Linux. Because people commonly want to run their C2 on Linux because it's easier. You can just do a cloud instance more easily than Windows. Although you want to run your implant on Windows usually because it's easier to run an implant on Windows typically. So that's ironic. There was a version of Go Mimikatz that used Go Donut in the implant.
Oh,
and
cool.
and that is actually something you wouldn't normally do, right? So it was a bit of a joke. It was so ostentatious. This was like a kind of a middle finger to people trying to detect Go binaries or Go malware. Because it was like, look, we can include a utility that should only ever be in the C2, which converts executables to injectable shellcode. There's like no legit reason this should ever be running on your Windows machine, like ever. But like, we're just going to download Mimikatz directly from the network, save it in memory, and then while it's still in memory, we're going to make it into an encrypted injectable shellcode, which is going to be encrypted differently every single time we run this program. So good luck seeing that. And then we're going to execute it still from memory without ever touching disk, now in its encrypted loader form, right? There was a version of Go Mimikatz that worked like that. And that uses a lot of utilities that I worked on or contributed to under the hood. And I like the source code of that project, I was just like, it is a very, if you could read Go code, it is a very short summary of most of what we've been up to for the last like 2.5, 3 years. at least in this space. But it might take a little, if you don't know what the repos are, you might have to follow some links to figure out what's going on. But one of the other big libraries in there is the debug library, where we started from a Go standard library that had file format parsers for executable formats for all platforms. So they had a Windows PE parser, they had a Linux and a BSD ELF parser. Well, some BSDs use ELF. It also has a Mach-O parser for OS X. And there was a library in Go that had parsers for all these file formats that were mostly complete. So they were a little buggy and they were missing bits here and there, but they were mostly complete and they were in Go. It started out a couple of years ago. I wanted, the backdoor factory stopped working, which is this old Python script that you could run on a Wi-Fi pineapple or whatever. You could man in the middle of people's downloads and inject shellcode into them. And there was a time when before everyone started using TLS, there was a little sweet spot there where you could get people to associate with your malicious access point, and like they, actually they would download unencrypted binaries and run them, and you could just like put shellcode in there and like you could like pop a lot of boxes that way. And I kind of missed that. I wanted his work again. And Josh Pitts, the guy that wrote the original Backdoor Factory, had said he was going to stop maintaining it. And, this was a few years after I started the RatNet thing. So I was pretty comfortable with Golang, network programming and encryption, stuff like that. And I was like, I think we could rewrite the Backdoor Factory in Go, right?
Mm-hmm.
But I wanted to do it cleanly. I wanted to not just rewrite it, but kind of refactor it so it was actually modules that could be maintained and extended and reused for different things. And the original Backdoor Factory, I love Pitts, but it was thousands and thousands and thousands of lines of spaghetti code. It was Python spaghetti code. And it was, you can go look at it. He's actually started maintaining it again because I think we shamed him into it. He saw how excited everyone was at our rewrite, and he was like, "Oh, well, they're that excited about the copy. Like, I'll bring back the original, right?" So he's been working on some new cool stuff in the Python version. So that's cool. But so for the Go version, just to get the backdoor factory working, I needed the ability to parse every binary format because we wanted to inject shellcode for OS X downloads, for Windows downloads, and Linux downloads. Like the rule across the board for most things is when I write in Go, I want it to work on all platforms. And so we found this library where it could parse all of it, but it couldn't regenerate it. Like you couldn't edit anything, right? So we forked it. We forked the standard Go library, and we added the ability to, it parses the binary into structs. Then you can change the struct fields, and then you can have it spit the binary back out, and it will have your edits in it. And so we have that capability for all three binary formats. And that is it's in the binject. It's a GitHub that's in the binject project in the debug repo. So that debug library has enabled almost all of our other tools and so many other tools. Like having that basic functionality has allowed us to do all kinds of other stuff. Like that was the key that unlocked all this other stuff. Because I'll give you some weird examples. Now we also extended. We can't just we not only can we parse executables out of files with this library, we can parse them out of memory, which means that we can use this. You can use this library to open up your own process in your own process space and parse it. You can parse yourself, and once you have parsed yourself, you can then see your own import table and your own export table, and you can see. You can parse the libraries that you have loaded into your process space and see what they export. And this has let us do all kinds of other stuff. Like, for example, one of the things that's in Binject is we wrote a demo loader. It's called Universal, and it is it loads a binary without touching disk. So you just give it a shared library, you give it a shared library, and it does a reflective DLL load on that shared library without touching disk. So you can send your implant a library over the network. It keeps it in RAM, and then it just loads it into its own process space directly, and it can run stuff in there, right? And that's what Universal does. It's a reflective but it works on all platforms. It works on Linux, it works on OS X, it works on Windows. But that means because there's a different system loader for all three platforms, that means that there's a different implementation under the same interface. There's a different backend implementation for each platform, right? So for the OS X implementation, for example, there is in the DILD library, the DYLD library, which is the dynamic loading library in OS X, there is an exported function call, which lets you load a library from a buffer in memory. Literally, OS X is the only operating system that lets you do exactly what you want to do in this sense as a piece of malware. It's like every other operating system is like sketchy about going directly from memory to loaded library. They're like, no, we would really prefer that you touch disk first because disk is where we're going to detect you, right? Yeah. If you never touch disk, we can't very well like scan memory all the goddamn time. It's too big. That's prohibitively slow, right? Like just numerically speaking, like when you touch disk, that's a slow bottleneck anyway. And that's like, that's where we can detect you. Like we can see you touch the sketchy file, we can set up a tripwire, no pun intended, but it kind of worked out that way. But, it's like disk is where you get detected, right? That's why the reflective loader is useful. Anyway, so OS X, for whatever reason, the DILD library has a function that does this magic malware thing just for you. And all you have to do is call it and it does it for you, right? But in order to call it, you have to find it. In order to find it, you have to parse your own process memory. So you have to walk through all the headers of loaded libraries in memory until you find DILD. And then you parse DILD to find DILD's exported symbols. And then you look for the exported symbols that you need to call to do the load directly from memory to loaded library. And then you call directly into them, right? So all of that stuff where I'm parsing through my own process memory, we use debug for the debug library. Right. But it also got used for Banana Phone, to do a similar thing on Windows. So on Windows, you parse your own process. You look at the PEB, the process execution block. You look at the libraries that are loaded in your process, and you can then go to the address of those libraries. You can parse those libraries in memory. You can parse their export table. right? And you can call, they're already in your memory space. You just need to find them. You can call symbols in these libraries that have already been loaded without having an explicit reload of the library.
Nice.
Right? And why that's important for an injectable implant is you can actually make shellcode using this debug library. You can inject into another process, a Windows process, and you can have it start making calls with all of the libraries that are already loaded without ever triggering a load library. All right. And most of the calls that you want to make are in libraries that are already loaded. NTDLL, kernel 32. Honestly, if you want to do some scary stuff with sound, it's like WinMM, and that's probably loaded too. Like the crypto library is probably loaded. There's a bunch of stuff in Windows that's probably already in your memory space. But what Banana Phone adds to this is hellscape. So you want to avoid the load library thing because that's like a thing EDR might pick up on, right?
Mm-hmm.
But to make it even kind of more Jedi.
Hey Ben, we're going to take a pause now. Stay tuned for next episode where we continue this exciting conversation. Thank you for listening to Hacker Talk, the podcast by hackers for hackers. Subscribe to Hacker Talk and share it to your friends, family, and social circle. And I will see you in the future.